Hello again, and we're back with Filip Hric, who started out as a tester in Slido. He's a Cypress ambassador, was a keynote speaker on the Apply Tools Front-End Test Fest, and his mission is to teach developers about testing and testers about development. So he's going to do a topic that requires us to pray to the live demo gods, because it's full of a sequence of little demos to show us how to track and find and debug the nastiest of bugs. It's going to be very example driven, and it's going to be more on the qualitative and not so much on the quantitative side of data. Filip, over to you.
Thank you. Thank you very much for the lovely introduction. I'm really happy. I'm really happy to be here. You see, my voice is already breaking. Really happy to be here. Thanks for inviting me for this wonderful event. I've seen that there are people already active in the chat, so I encourage you, if you have questions throughout the presentation, feel free to ask them, and I'm hoping to get to those at the end of the presentation, which I have called Blink and You'll Miss It. And I'm going to be sharing some stories from discovering the most annoying test flakes. But what I like to do is to look over to the audience, and we're not live. Well, we are live, but we are not in the same room together. But when I'm in the same room with the audience, I like to ask a bunch of questions at the beginning. And the first one is kind of obvious one, right? Are you writing end-to-end tests? I'm assuming if you came to this presentation, the answer would in general be yes. So there's a follow-up question to that one. Has your end-to-end test ever failed? I'm again going to jump into assumption that probably, yeah. If you haven't seen your test failed, you might not want to trust them actually. So make sure you see your test failed. Has your test ever failed and you weren't sure why it failed? If we were in the room right now, maybe fewer hands would raise up above, and maybe some of you would still hold your hand up. Have you ever spent more than 1 hour debugging your tests? Has that ever been the case for you? I can safely say that it has been a case for me. Have you spent even more, maybe 2 hours or more than 2 hours? Have you spent more than a day debugging a test flake or a test failure? I have to admit, I have been there. And if you have been there too, you maybe feel a little sad right now. I hope I'm not resurfacing some trauma. But if you answered yes to the latter questions, you may have experienced frustrations that come with UI end-to-end tests. So this presentation is, I'm hoping, is going to be about possible ways of reducing those frustrations. Now, at the risk of half people leaving up my presentation, I'm going to show the testing pyramid. You probably know this model. I think like everyone knows this model. It's been in every testing presentation for the last 15 years. And I'm showing it as well. At the top, the end-to-end tests are costly and slow. Unit tests are cheap and fast. And today I'm going to be talking about the top of the pyramid. But I believe that this model is kind of outdated. We have much better tools nowadays. And especially if you look at the top right corner with the dollar signs, I think the cost of creating a test is not so high anymore. And as a result, what we have today is we have a lot of end-to-end tests. But let's stop at this little guy, which is at the top left side. And that's the speed of tests. We tend to think that end-to-end tests are really slow. And as I said, we have some great tools nowadays. But they all seem to be battling for speed of execution. We're looking at which one is the faster. I have read countless blog posts comparing Playwright and Cypress and Selenium and some other tools, and they all seem to be focusing on how fast will the test execute. But if you answered yes to any of the questions that I answered at the beginning of this presentation, you know that there's a difference between speed of execution and speed of maintenance. And the funny thing is, is that we sometimes don't notice this, right? When it takes 30 minutes for your tests for your tests to run in your pipeline, we as developers or testers are happy to spend a month of our time migrating from one testing tool to another so that we can take it down to 25 minutes, right? And we do all this work just because we believe that maintaining tests is just too much work. We're still mentally living at the top of that pyramid. We're still using that model. And to be completely honest, I think in many ways, we really are living on top of that pyramid. So here's an example. We have these so-called strategies of helping us live with the fact that our tests are flaky. I've seen these strategies across many companies I've worked with. Strategies like muting a test or quarantining a test, putting it aside, maybe retrying a test, adding a longer timeout, reproducing a test locally, deleting a test, or as I like to call them, shock, denial, anger, bargaining, depression, acceptance. So that's a little side joke here, but these strategies exist because we have limited visibility to what is happening on CI. As they say, what happens in CI stays in CI. And many times what happens when our tests fail on CI is that we're simply left with an error message. That error message may look something like this. And the main problem when dealing with end-to-end tests is the lack of context, right? End-to-end tests usually copy some kind of user story. So when an element is found, it tells us pretty much nothing about what exactly has failed. And when tests end up with an error like this, the problem is that the problem that actually caused the test to happen or caused this error that we see, it may have occurred like a couple of steps before, right? So we are lacking context. And I want to share a couple of stories with you that start with maybe some mysterious message like this. And these are stories that I either encountered personally during my time as a tester or consultant, or with our clients at Replay, where I currently work at. So one of those clients is Metabase. Metabase is business intelligence software. What's really beautiful is that they're open source, and I really recommend you to take a look at their code and see how a large test suite looks like. The team has done an amazing job there. But as always, when you have a large test suite, you have a lot of flaky tests and a lot of problems. So we came in and helped them drive down their test flakes. They have hundreds of end-to-end tests and quite a big of test flake. And with the integration of Replay, we were able to drive it down to practically zero, or zero on the main branch, but like any new test flakes that were introduced could be fixed quickly. So let me show you an example. This is a fairly simple test. The team wanted to make sure that that users with slower connections know what is happening. So they would have this simple test that would make sure that the loader animation is visible. And the test actually failed over and over, which was really strange because before it was passing and none of the codes that it was testing has changed. And this was really frustrating for developers. Why are my tests suddenly failing? Why did the spinner not appear? So we recorded their test with Replay browser. We recorded it on CI and then started debugging. So what you see here in this video is Replay DevTools. It's pretty much like having a Chrome DevTools, but in CI and with time traveling capability. So on the left side, of this video, you can see that as we zoom in, you'll see this number in a blue in a blue square or something like that, and that one indicates the number of executions. So not sure how well you see it, but it shows 27 times. So that line of code was executed during the test run. It was executed 27 times. So we can time travel to every execution of that line of code. And as you can see, there's a command click which you can use to go to that, to a particular execution. And there we can see, and we can see that on the right side in the view, that there was clearly a moment where the spinner element appeared. So this is kind of strange, right? Why was the test failing when the element clearly appears? Was the test going too fast for the test to catch it? Or was the application going too fast in order to for the test to catch it? And the answer is yes. Now, Metabase was actually smart enough to think about this, and they have implemented this throttling strategy. So while the spinner was waiting, it was there to wait for a response from a server. So in order to catch that spinner, Metabase team would implement this throttling strategy, and they would slow down their request by limiting kilobits per second, which is very smart. But there is one catch. When the response comes from the URL, it's going to resolve in different time if the response is, for example, 100 kilobytes big versus when it has 1 megabyte. So in the end, when the response from this URL was smaller, the test ran faster, and the spinner showed for a shorter period of time. In fact, it showed for such a short time that Cypress, the Cypress script, was not able to catch it. So in the end, the solution that was implemented to make the test stable was really simple. Instead of set throttle to limit the amount of kilobits per second, they have set up set delay, and then the test was fixed. And this was largely due to the fact that we were able to time travel to the line of code, and we were able to record their test on CI where the failure actually happened, because trying to reproduce that locally would always pass. There would never be a problem if you try to record that locally. All right. There's another use case from Metabase which I want to show you. This was a test flake that actually inspired the name of this presentation. Blink and you'll miss it. In fact, what I'm going to do now is I'm going to show you a screenshot from failing and passing test side by side. So you see two images side by side. One of them is the failing test, and one of them is the passing test. Can you see which one is which? Or can you even see the difference between those two? If you see, you have amazing eyes. I actually want to show you in a video. Can you see it now? Can you see it going back and forth? The difference is really minimal, but this is what actually caused the test to fail. So it was a simple CSS change. But what's really interesting is how it actually affected functional side of things. This was kind of most confusing part of it. This is what the error message that we have seen. The error message, there was nothing that pointed to a problem with CSS. In fact, it really looked like a functional error. Sorry. Because what we expected was some data. We expected a certain date range, right? There was a graph, we did a drag and drop, and we were expecting that the date range would start on April 1st, as you see over here. But it actually started on May 1st. So that was kind of a strange error. To give you a better idea of what the test did, here's the test code. This is how the test looked like. This is the original test. Now, the test tried to select a range, and it did that with a series of trigger commands. It would do the mouse down, then mouse move, and then mouse up. So sort of a drag and drop action in 3 commands. And it tried to select a certain range. And then it would try to validate whether that range was indeed selected. And this is where things failed. Now, usually when you have a problem like this, when you look at a data problem error, the first instinct is to go to look into the network panel. And since we recorded those tests on CI, we were able to look into the network panel and confirm that the date range that was selected was indeed on May 1st. So test was actually selecting the range from May 1st. So our test was doing something we didn't really expect. It didn't behave the way we wanted. And going back to the video comparison, we can actually see why the test did not work the way we wanted. The CSS changed. The CSS change caused the whole layout to shift slightly. So Cypress commands that relied on precise coordinates on the page when selecting something were different after the page uses slightly bolder fonts. Not sure how well you can see that on this video, but you can see the text is sort of changing from bold to thin, and that is what actually caused the trouble. Now, this would normally be super hard to debug, but since we had that data pulled from the CI execution, we were able to find that fairly quickly. In fact, I believe this was just a couple of minutes of debugging. So that's sweet. All right. My next story is very common. If you are testing, if you're writing end-to-end tests, chances are you already seen an issue like this, race condition. So here's an example with a very simple e-commerce site. It's a shop or e-commerce site where you can buy a sneaker, and we've written a test that attempted to buy that sneaker. And it was flaky. Sometimes it will fail, sometimes it will pass. And when it failed, we would see that we would click on the button too soon. So on the left side, you can see the code that we have used. On the right side, you see the page. Now, we try to fix the test, right, by adding weight to this test, which is, you would say, probably not the ideal solution, right? It's a slippery slope because we may be increasing the time, but we are not really fixing the real problem. So I actually want to dive into this one with you and show you how a debugging process might look like. So let's debug this together. We're going to dive into the code and figure out what actually made this test flaky. And here's what we know. We know that test opens a page and clicks on Add to Cart button. We know that this test sometimes passes and sometimes fails. We see the error. The error said that we wanted to find a cart product added to cart, but what we actually had is a message that said cannot add 0 items to cart. So something fishy is going on here. Test seems to click on the add to cart button too soon. Test runs locally fine. Everything is fine locally, but it actually fails on CI, or sometimes it passes, sometimes it fails. And the application that we are using uses REST API to fetch data. So there's some backend communication going back and forth. All right, so let's now jump into that. So now I'm sharing my screen with you with the recording of that test. I'm going to make this slightly bigger so you can see that well. But here I have a recording of my test execution. So I have a failed test and I have a passing test, and I can take a look into the details of both the failing test and the passing test. So here's what we have. All right. So this, if you have never seen this is sort of this is the replay interface. These are the replay dev tools. It's like having your browsers in your browser DevTools in your CI, and you can travel back in time and stop at any point of time. So here's a timeline where we can jump back and forth and see our test being executed. We can play it like a video, but what we want to do really is to debug what's happening. So what I'm going to do is I'm going to open this failed test, and what I want to do, if I take a look into how the test actually went, I can see all of my commands. I can see visit, I can see contains, I see my assertions, I see the click, and what I see also is my XHR requests. So I'll head over to the right side and open the network panel, where we can see all of the APIs that have been made during this failed test. So I'm going to go ahead and filter all of the fetch requests. So we got a bunch of those, and I can see there's some dev JSON, and I have two API calls, and one of them is passing. It's giving us status 200, and one of them is failing. That one is saying add to cart, and we got a response, cannot add 0 items to cart, which is interesting. This is probably our first clue into that something is slightly off. Now, you can see that I have a preview of my application from this exact moment. So I can make this view bigger and see the exact moment when that click happened. And there are a couple of interesting things happening in here. First of all, we see that the sneaker is not available, and the number of sneakers is 0, and and that's pretty much it. So this is suspicious. This is not something that we want to see. So what we can do, we can add comments, but that's not what I wanted to do now. We can go ahead, try to take a look at this click action that happened during our test, and we can jump to code. So when I click on this button, jump to code, what's going to happen is that these DevTools are going to take me to the exact line of code that was executed when that click action happened. So we have this very nice connection between our test script and the application that we are testing. So I'm going to hide this side panel for a moment and just focus on the code that's over here. Now, I see number of lines and how many times they were executed. So I already know that there is some problem with the add to cart API call, right? And I can see that when I click this add to cart API call, is what's being called, right? Wait, I wanted to, here we go. So when we click, this add to cart function is called, and our add to cart API call is being made. So let's take a look at what this code is actually doing. It's adding our items to cart. Now, it uses the method of post, it has some headers, and here's the body of our API call. So what I can do is that I see that there's this QTY quantity body being shown. So what I want to know is what this quantity actually was. Let's try to take a look. Now, usually when you are using DevTools, you have your console available. And if you're interested in what your code is doing, you normally add a console log. Now, in Replay DevTools, you can do that as well by clicking on this plus symbol. It's kind of the same thing as if you would add a console log into your code, but now we're not modifying the code, we're just looking at the recording of our test execution and our application. So as you can see, when I add this plus symbol, something is going to print out in my console. Now, if I want to change that, I can do that. Let's do hello world. And now my console is going to say hello world, but that's not really useful. What I'm really interested in is this quantity. So let's print out the quantity, and now we can see what we are sending to the server. Now this is rather curious. We are sending number 0 to the server. Are we trying to buy 0 sneakers? It seems that way. And it seems that when I go back to my passing test and look at the same execution, now that number is 1. So let's annotate this a little bit more and try to see where this quantity is coming from. So sent to server quantity, let's give it a purple color. And now we have this console log nicely annotated. All right, let's go back to the failed test and keep on debugging. So where does this quantity come from? Well, why not search for it? I'm going to type Command F and look for quantity. Quantity, if I don't make a typo, it will appear. And I can see we have it appear in the counter. That's where we are using it. So that's fine. But where is it defined? It's defined at the very top of this React component. So if you're already familiar with React, you know what this is. If you're not, it's fairly simple. This quantity is like defining a variable, but it's actually a state variable. So in React, we define a state variable, and then we define a function that changes that variable. So we have this quantity and set quantity sort of pair of functions. So this use state means what is the default state of that. So that's set to 0. So let's try to see where this set quantity is actually being called. So I'm going to search for set quantity now. And here I see that this piece of code is actually calling the set quantity function. So this is where that 0 changes from 0 to something else. Well, how does it change? Well, it passes on this data QTY. Where does the data QTY come from? It comes from this constant, data. How is that constant even made? Well, it's being fed by the data from API, this fetch availability function. Where is that fetch availability function come from? Well, it comes from this definition. What does it do? It will check availability. So let's go back to our network panel and try to look at our fetch XHR to see what we have here. So we got 2 API calls. We got check availability, and that response will say what the quantity is. Now this quantity is then fed to the set quantity function to change the number of available items. Hopefully you're still with me. All right, and then we want to use that quantity and send it over to server. Now it seems like this is not happening, but let's take a look. Let's take a look at what this data QTY was when this line of code executed. So I'm going to do fetched from server. Actually, let's do quantity fetched from server. And I'm going to add data QTY. And let's give it a green color. All right, now this is interesting. We are sending number 0 to the server, but from the server, we're getting back number 1. This is rather strange. Let's take a look now at our passing test. If I go to my passing test, I see that the quantity fetched from server is 1, but what's being sent to the server is also 1. And what's really interesting is the order of these console logs, because these actually appear in the order of how the lines of code were executed, which means we do have a race condition. We are clicking on that button too fast. Our test doesn't really care whether that check availability API call has made it all the way back. It actually just clicks on the button as soon as it is possible. Now, what usually happens when we are dealing with CI executions is that we're saying, oh, the test is going too fast. But what I think it really is doing is that it reveals problems we already have, right? If you take a fast execution on CI, you can scale it down and take a look at a very slow machine that a user has. Now, everything is going to load very slow for them. So they might end up having the same problem. They might click on the button way too soon and actually try to order 0 sneakers instead of 1. All right. So let's continue. So how do we fix that test? Well, as I mentioned, there's this counter component that's in our application that uses this quantity. That was the plus minus symbol you might have seen there. And then there's the add to cart button, which we actually click on when we want to buy some sneakers. So in order to fix that, we can go ahead, and when the number of quantity is anything else than 0, we're going to add the is disabled property to the add to cart button component. Now we should add it to the button component as well. And then we can add an HTML attribute is disabled, so that when we have 0 sneakers available, we will not be able to click on that button. And then add some styling, so we make this button semi-transparent, and now our test is fixed. So as a result, our code becomes much cleaner. This is what we had before. We had to add a CY wait. We had to wait for 1 second in order to the page to be fully loaded. But now we can take this out. And this is what you should do as developer who owns test flakiness, right? You don't want the users to have the same problems as your tests have. And it accomplishes 2 things. First of all, it fixes hidden issues that customers actually have but never report, and it makes your test automation more stable and therefore more reliable. I'm very confident that more than 90% of what we call flaky test is actually flaky app. It has nothing to do with the test code itself. This is how our test should look like. This is fine. All right, let's go to one more example. We all like our tests to be green, right? But there are cases where green test actually hides a real issue. And I want to share a story like that with you. So here's a false positive flake that we have started with. This is how a test looked like. We had a before each, we visited a page, we waited for a loader to disappear, and then we would have 2 commands, inject X and check accessibility. So this is a Cypress plugin that checks all the elements on the page and makes sure that the accessibility is that all the accessibility checks are passing. Now, what was really frustrating about this one, that this test became flaky, but what we actually wanted is that test to fail all the time. In fact, when it passed, that was the problem. We had a false positive in our code base, and we needed to fix that. So let me show you how that looked like. Again, I have some tests over here, or recording of the tests over here, which I'm going to show you. Now I have 2 tabs open over here. I have the failed test and I have the passing test. So let me take you to a place where you can actually see something. Here we go. Now visually you can see that they look kind of different. There's this modal window in the failed test, and that modal window is missing in the passing test. And some of you already kind of know what's going on here, right? So, but let's break it down a little. So here's our failing test, and we can take a look into it, into what the test was actually doing. We see all of our Cypress commands. We see that we visited the page, we waited for the loader element not to exist. Then we injected the accessibility script, and then we did the accessibility checks. Now, what's kind of funny about these accessibility checks is that when we get an error, it looks kind of like this. We have found 2 accessibility violations, but we expected there to be 0 of them, which is kind of a non-telling, right? And ending up with error like this it's not going to help you really debug the test or even figure out what is going on. The nature of Cypress command is that they sometimes hide what's going on behind. But what we can do, we can actually see these violations. So we can go ahead and jump not only to the application code, but also to the test source. So when I do that, it will take me directly into the code of that accessibility plugin. And we see that on this line of code, it returns the violations. So what I can do now is, again, to add a console log or to add a print statement to kind of reveal what was actually happening during that test. So let me print it out. Let me print out the violations and see what's in here. All right, so now in our console, we can see two violations. We have button name, impact critical, buttons must have discernible text, and it seems like this one is not having that. Here are all of the details about the problem. So accessibility plugin does really good job of that. So what we can do is we can take a look at the exact node, the exact thing that caused the problem, and we can see this element over here. It kind of doesn't have like too much information about it, but we can see it's button class absolute top. So what we can do is to go jump to the elements panel and try to search for that. As I search for that, I can see that this is the element. Now in the viewer, as I click on this, you'll see that element highlighted. So this is the problematic element. It contains a button that does not really have any accessibility attributes, and therefore it's inaccessible. People with accessibility problems have problem with noticing that that button is there. All right, so now that we have searched the elements, that's great. We know what's going on. But what we can also do is to not only look at the elements panel, but you can see there's a React panel as well. So if your application is written in React, you can debug even that. And here's a selectable or inspect element thing going on. So I can go ahead, click on my model, and this will take me to the model component. I can even search within the components. But here's the model component, and that is kind of problematic. I can see the properties, that it is open, and I can go ahead and jump into the code, into the definition of that model component. Now here again, I can see how many times this code was executed, and let's try to compare that to the passing test. So when I go to the passing test, I can go to the DevTools and I can search for a model.tsx component, and this is actually what kind of hints what's going on here. In the failing test, we see this component being called. In the passing test, we actually don't see that. So when our component, when our model window appears, our accessibility checks fail. When our test passes, the model does not appear, which means it is the model window that actually has the problems. Now, since we have recorded those tests, we are able to see that. So now what we can do is we can, now that we know what the problem is that we have that the test, when it was testing, it has done the accessibility check too soon. It has done it before the model appeared, and that gave us the false positive. So what we need to do is we need to make sure that the model is present. We need to check the model presence first. So we go model should be visible, and then we'll do the accessibility check. So these are just a couple of stories, but there are definitely more. And I could probably talk about them for hours, but I only have limited time, so I'm going to wrap it up now. Here's the thing about test speed. As I mentioned, we obsess over speed of execution of our test tools. Now, I have shown a lot of examples about Cypress, but first of all, Replay works with Playwright as well. And most of these problems, actually all of these problems, would appear in Playwright as well. There has been a very nice discussion on LinkedIn going on recently that testing tools are not actually the cause of flakiness, which I partially agree with, but this kind of demonstrates the point, right? We can have the faster execution, but test flakes will not go away. As I mentioned, we obsessed over the speed of execution of our test tools, but this is actually what we should be looking at. How long does writing tests take? How long does the debugging of your tests take? If we want to drive down if we want to make improvements to our speed, we can do that only by driving down the debugging time. That way we can achieve real speed improvements. All the test flakes that I have shown you would normally take hours or even days to figure out. Maybe they would even be impossible to figure out. But when you have the option to time travel, you can take it down to minutes. So thank you very much. It has been, again, a pleasure to be here to talk to you about my favorite topic, which is flaky test. If you found Replay interesting, you can scan the QR code on the left to give it a go. If you're interested in going over to my slide, it has links to those replays that I have shown. You can scan the QR code on the right, and I'll be happy to answer any of your questions if there were any. See you around. You can follow me on Twitter, LinkedIn, wherever, and I'll be happy if you send me a message. So thank you very much.
Thank you too, Filip. And I have one question, and I'm sorry that it's going to be about the AI hype again, but how is testing profession going to change, according to your opinion, with AI coming into the game? Because we already know how it's working out for developers.
Yeah. So I had a slide about this topic in my recent talk, Test Like a Developer, Develop Like a Tester. And I made a appeal for the testing community to become more technical. Because if you have interacted with ChatGPT or some other AI thing, you probably saw that it will give you an answer, but you kind of need to check it. You need to make sure that the code it's spat out is actually working, is actually the thing you need. So there's a lot of not only human input, but actually human expertise. So I think, AI is going to take some of the jobs away. But if you want to make sure that it doesn't take your job away, you need to become an expert at what you do. And that way you can be the person that checks after the AI whether the thing it's spitting out is actually good. Because it's being modeled on some horrible code that's out there. Is being built on top of some good code that's out there. But distinguishing between good and bad, and distinguishing between the actual intention you have, that will always be a human domain as far as I can tell. So so that would be my advice. Get more technical, get more knowledgeable in your area of expertise, and you should be fine.
Yeah, I don't really think that AI will take our jobs. I mean, I'm hoping it's going to take all the housework away from me, but that's not where it's headed at the moment. But maybe I think one of the things that it does well is munch a lot of information to so that you don't have to. So in these very long hours of trying to find something, I'm not sure it's going to be a chatbot as such, or like if you're going to have to become better at prompt engineering or something else, but it's going to be interesting how it can help you track down issues faster.
Yeah.
And of course, obviously, the fact that a lot of the code is going to be AI generated is also going to affect testing.
Yeah, exactly. So I think we're safe, but we'll see what the future will bring.
Yeah. Thank you again for the great talk. It has been very entertaining and informative at the same time. And to the audience, we now have a 1 hour lunch break, I think. Am I correct? Or do we have another topic? Yeah, maybe another topic and then an hour lunch break. So have a nice break and see you later. Bye.
See you. Thanks for having me.